Okay, welcome to Algebra 2 Notes for Section 4.3. This is page 1, and in this section we're going to learn how to multiply matrices. There's actually two types of multiplication. There's an easy type that we're going to learn at the start here. It's called multiplying by a scalar number. And later you're going to learn how to do the more difficult one, which is multiplying two matrices by each other. Okay, when we multiply, we're looking at scalar multiplication here. When we multiply by a real number, just a number like 5 or 2.3, negative 8 or 1/2, that number that is not in a matrix is called a scalar. And on page 2, I'll do my best to explain why what we've been calling numbers all along is called a scalar in this context. And it does contrast with the word matrix. So let me show you the scalars in these next four problems here. Example 1, A, B, C, and D. And I'm going to highlight them in pink so you can see them here. But the scalar here is 3. We're multiplying 3, the scalar, times the matrix 5, 6. In the next problem, the scalar is 2.1, and we're multiplying it times the 1 by 3 matrix, 10, 4, negative 3. In example C, we have a fractional scalar. We're multiplying by 2/3. And finally, we're multiplying by an irrational number pi in the last example. Now, if you study those last four examples, you're going to see that it's really easy to multiply a scalar times a matrix. You simply multiply the scalar by all of the elements in the matrix, which makes it look very similar to what you did when you used the distributive property. You had a multiplication on the outside of a parenthesis in that case, and you multiplied by each of the members inside the parentheses. Well, here you do something very similar. So to start out here, I'm going to multiply 10 times 4, and that'll change the 4 into a 40. And then this 10 times this 5 is going to make that 5 turn into a 50. And we do so throughout. Multiply all of the numbers by 10. So the 6 becomes 60. The 0 stays 0 because 10 times 0 is 0. And you finally get 110 down in that corner. Okay, with that under your belt, this should be very easy. I'm going to multiply all four of the elements in this 2 by 2 matrix by negative 1/2. So you get negative 4. Negative 1/2 times 6 would be negative 3. Negative 1/2 times 10 is negative 5. And finally, you get positive 3.5 on the last one because negative 1/2 times 7 is 3.5. Okay, 2.1 times 4 is 8.4. And 2.1 times 8 is 16.8. So our new matrix is 8.4, 16.8. Now, in example D, we have a little bit of an unusual problem here. We're multiplying by a scalar that comes in the form of a variable. So we're going to multiply that x by the top element. X times this 3x minus 2 would be 3x squared minus 2x. And then finally, x times this x plus 4 would be x squared plus 4x. And you can see that I had to apply the distributive property in the middle of that scalar multiplication. Okay, example E, we're supposed to come up with the result of 2 times the A minus 3 times the B. So I'm going to start out by writing it out. Okay, 2 times the first one is going to be 4, 6, let me do that right, 4, 6, 0, 2. So that little 2 by 2 becomes a new 2 by 2 matrix that has elements that are twice as big. And you want to keep the minus sign there and multiply by 3 instead of thinking of it as negative 3. So 3 times 1 is 3. 3 times negative 1 is negative 3. Then you get 12 and 9. And now you're going to take this minus and apply it. The top left corner, this is how you do the subtraction. We learned that last lesson, is going to give a 1 there. And let me change colors here so you can get some color coding going on here. 6 minus negative 3 would give 9. And the reason it gives 9 is you've got a double negative going on there. It's more like 6 plus 3. All right, let me choose a purple color now. 0 minus 12 will give negative 12. And let me get another highlighter color going on here. Let's go with just a yellow. Okay, 2 minus 9 is negative 7. Don't forget the braces. They're part of the matrix notation. Okay, so that does it for page 1, and you now know, I hope, how to multiply by a scalar. We'll pick up on page 2 in the next video.